Hello everyone, today we're going to look at section 4, which is on gravity and weight. If you pick up a ball and let it go, it falls downwards. This is because the Earth exerts gravitational force on it. The force with which the Earth attracts any object is called the weight. You know from previous chapters that all objects under the influence of gravity alone move with the same acceleration. And we have introduced you the letter G to represent the gravitational force before. And in your exam, we normally use 9.8 for G. So something you have to be very careful with is that in everyday language, we tend to use weight to mean mass. For example, if you buy a bag of apple and you might say the bag of apple weighs 1.2 kilograms. So however, in mechanics, the 1.2 kilograms is actually the mass. If you would like to find out the weight for this bag of apple, what we could do is actually to work out the force, because weight is a force. So that means weight of this bag of apple would equal to the mass 1.2 times by the gravitational force, which is 9.8, and that equals to 11.76 Newton. Okay, so here's a key point you need to remember, which is written in the red box on top of the page. The magnitude of the weight force on an object of mass m is W equals to m times by g, where g equals to 9.8 meters per second squared. Its direction is towards the center of the Earth, which is normally described as downwards. The mass is a property of the object itself, independent of where it is. The magnitude of the weight force depends both on the object and the properties of the Earth. If we're on a different planet, the weight could be different. So, for example, the gravitational acceleration near Mars is actually 3.7 meters per second squared. Even on the Earth, the gravitational acceleration is not exactly the same everywhere. It depends on the latitude or the altitude. For example, G is a little bit lower on top of a mountain than at the sea level. So you could be asked a question where it's not really based on Earth. So read the questions carefully when you do the exam questions. Okay, so let's have a look at an example. Right, so in example, here says in his house on planet X, Zuzo has a crystal ball suspended from the ceiling by a light, inextensible string. The mass of the ball is 1.6 kilograms, and the tension in the string is 18.7 Newton. Find the magnitude of the gravitational acceleration on planet X. So as you can see here in this question, because it's on a different planet, that means the gravitational acceleration is not simply just g, which is 9.8. And hence, we have to use other information to work out the new gravitational acceleration. So why don't we start by draw a little diagram? Okay, so let's say I'm going to use a circle to represent the crystal ball. So what do we have? Well, as we know that the crystal has mass 1.6 kilograms, which means it will have a weight, and the weight always acts towards the center of the planet, which is downwards in this case, and let's label it with W. And we know that W equals to m times by g. Now be careful here, I use g, but g is not 9.8 in this case. What else is acting on the crystal ball? Well, it says the crystal is suspended from the ceiling by a light, inaccessible string, and the tension in the string is 18.7 Newton. So if it says the light, inaccessible string, that means we can ignore the mass of the string. So the tension, now remember from the previous section, tension goes outwards. So that would be 18.7 pointing directly upwards. Okay, so now we know that the force is balanced, so let's use our Newton's second law, F equals to ma. The resultant force acting on the crystal ball will equals to, now here it depending on which direction you pick as positive direction. So let's say if I pick going downwards is the positive direction, then what I would do is I would say the resultant force would equals to W plus negative 18.7 equals to the mass, which is 1.6, times by A. Now remember, this A, which is acceleration, in this case is 0 because the ball is not moving at all. So it comes by 0. Okay, so what do we have here? Well, we have W minus 18.7 equals to 0. So that means W is 18.7. But we talked about before, what is W? W equals to the mass times by the gravitational acceleration. So we can then replace in our little equation here. So now we have m times by g must equal to 18.7. And m is 1.6. So 1.6 times by g equals to 18.7. So that means g equals to 18.7 divided by 1.6. And that cannot be 11.7 meter per second squared. Great. So hopefully from this simple example, you can understand how we could work out the new gravitational acceleration. Let's look at another example. Okay, so in this example, a crate of mass 87 kilograms is being lowered using a light inextensible rope. So again, here, this piece of information tells us that we could ignore the mass or the weight of the rope. Part A, find the acceleration of the crate when the tension in the rope is 750 Newton. Okay, so we have already been given a diagram, so we can see here. And what we have here is this 87G, that's the weight of the crate. So that would be basically equal to the m times by g times 87 times by g. Right, now we are going to find out the acceleration of the crate. So it says it's being lowered. So why don't we assume that the downwards is our positive direction, because that is the direction of motion. So, oops, sorry, let's get this. Okay, right. Now, what do we have? Again, let's start with our F equals to ma. Now, what is our resultant force? So the force acting on the object would be 87G, and that's positive. And we're going to plus negative tension. Now, what is tension here? It says it's 750 Newton. And that would equal to m, which is 87. Times by a. Now, a is something we're looking for. Let's leave it. Okay, so this g we can actually use 9.8. So you would have 87 times by 9.8 minus 750, and that would equal to 87A. So you can then point the calculator and work out the value of A, and A come out to be 1.18 meter per second squared. Okay, so let's write our answer down here. So we said A equals to 1.18. Right, let's have a look at part B. Part B, find the tension in the rope if the crate is being lowered at a constant speed. Now, constant speed, this is quite important. We have looked at this in previous section as well. If it's traveling at a constant speed, that means there's no acceleration. So that means acceleration A equals to 0. So let me write out this section so we have some space. Okay, right, part B. So we now know that A equal to 0. Okay, so we can still use F equals to MA, and our resultant force now equals to, again, it's the same thing, 87G. So why don't we just write 87 times by, instead of G, let's use 9.8. We don't know what tension is. Let's take away tension. And that equals to M, which is 87. But remember, we already said A is 0. So 87 times by 0, that's just 0. So you can see straight away that T, which is equal to 87 times by 9.8, and the tension comes to be 853 Newton. Okay, let's look at the last part of this question, and let's wipe out as well. Here we go. Part C. Find the tension in the rope required to decelerate the crate from 1.2 meter per second to rest in 3.5 seconds. So you can see here we have to use a super equation. So let's write down our S, U, V, A, and T. Do I know S? Not really, cross it out. Do I know the initial speed or initial velocity? Yes, it starts lower at the rate, not the rate, the speed at 1.2 meters per second. Do I know the final velocity? Yes, 0. And do I know the acceleration? Well, not really. So, but we could work it out because we also been given the time, which is 3.5 seconds. So we're looking for a pseudo equation which does not involve S, but U, V, A, and T. So I'm thinking this formula, V equals to U plus AT. So that means V is 0, so 0 equals to 1.2 plus A times by time, which is 3.5. So according to your calculator, you could quickly work out the acceleration. It will come out to be negative 0.343 meter per second squared. Now you would know that you have got it right because the acceleration cannot be a negative number, and in the question it has indeed mentioned decelerate. So that means we know that this probably is the right answer. Right, so when I know the acceleration, I can then use F equals to ma to work out the tension required. So again, let's start by writing down the formula. F equals to ma. Right. Here we go. So let's think about the resultant force. Just like we've been doing for part A and part B, the resultant force will be 87G minus the tension. So that would be 87 again times by G, and now I will just use 9.8 as G minus the tension, which that's something we're looking for, equals to the mass, which is 87, times by the acceleration, and we have just worked it out. That's negative 0.343. Okay, so hopefully you can read this number here. case, it's not very clear here, but it is negative 0.34 minus 3. So then you can put into your calculator and you can work out that the tension equals to 29.8 plus 853. And the final answer is 882 Newton. Okay, excellent. Now, let's look at our last example. So, what do we have here? A ball falling through the air is subject to a constant resistant force of magnitude 0.3 Newton. The ball starts from rest and takes 1.6 seconds for 12 meters. Find the mass of the ball. Okay, so there's quite a few things going on, and because it's been given time and also the distance the ball has fallen through, that means at some point we definitely have to think about the silver equation. So let's write down what do we know here. Well, let's draw a diagram. Okay, so here's the ball, and we know that the weight for the ball would be W equals to mg. And here it says the ball is falling downwards, so let's say downwards is our positive direction. There is an air resistance, so that is 0.3 newtons acting upwards, because the air resistance always goes in opposite direction to the motion. All right, so now let's use Newton's second law, F equals ma. Now, what is our resultant force? Our resultant force would equal to the weight take away 0.3. And the reason why it's take away 0.3 is because we're adding a negative 0.3 Newton, which means it's taken away. So let's write this down. So we have mg minus 0.3, and that equals to ma. So why don't we substitute the mass? Oh, sorry, we don't know the mass. That's actually something we're looking for. Okay, that's all right, but we can replace g, which is 9.8. So now we have 9.8 and minus 0.3 equals to a. So if we're looking for the mass, you can see in this equation, okay, if we can work out what is acceleration, then we will be able to solve the equation to work out the mass. So let's leave it here for now. And now let's find out what is the acceleration. So let's write down our S, U, V, A, and T. In the question, the ball has a floor of 12 meters, so S is 12. It started from rest, so U is 0. Now, do we know V? I don't think so, so let's cross it out. A is something we're looking for, so that's a question mark, and the time taken is 1.6 seconds. Great, so we're thinking a formula which does not involve V, so that would be S equals to UT plus a half AT squared. So that would be 12 equals to, okay, so this is great. If you use 0, the whole thing becomes 0, doesn't matter what time is, and plus a half comes by A, comes by time 1.6 squared. So by putting into the formula, and then put into the calculator, we could very quickly work out the acceleration A must be 9.375 meter per second squared. Okay, so then we could use it, this answer we got in our previous equation. So let's substitute the value back into the first equation. Move down a bit. Okay, right. Let's start substitute the numbers in. So we have 9.8 n, so basically the left-hand side stays exactly the same, minus 0.3 equals 2, and times by acceleration 9.375. So we can then subtract 9.375 m from the left-hand side, and that will leave us with 0.425 m minus 0.3, and that equals to 0. So with your calculator, you can very quickly work out m equals to 0.706 to 3 single figure, and the unit is kilogram. Okay, right. So by looking through those 3 examples, hopefully you have now got a good idea of how we could use F equals ma and also the silver equation to work out the gravitational acceleration, or the mass, or even the acceleration. So what I'd like to do now is to have a go at the questions from exercise 21D. Again, if you do not have a textbook, please pause the screen to try these questions, and the answer will be attached at the end of this video. So here's the question 1 and question 2. Here comes question 3 all the way up to question 7. Now we have question 8 up to question 11. And finally, we have question 12 and question 13. And here are the answers for exercise 21D.